This is 1121 mods 6 and 7. We're going to do the first part of 6 here. What I've got open here is just the notes that I use initially for both of these. You can take a quick look at 6. We'll review 7 when we get to 7. For mod 6, it's just 3 sections: 6.1, 6.2, 6.3, 6.1. Purpose of the data link layer. We'll go through that in this particular video. We'll come back. We'll do a second video for 6.2 for topologies. We'll go through the different types of topologies there. The main thing is the last thing there, that's CCNA, CA, and CD. So we'll talk about each one of those, not too deep. And then we get into 6.3, frames versus PDUs and frame parts, and we'll talk about that there. So we're going to try to be not super in-depth here in this particular slide, but I'm going to go ahead and move this out of the way. And we're going to do data link layer, module 6. So welcome to it. And the very first part, purpose of the data link layer. And they give us a really nice slide. And they say, well, you know, the idea is that we're going to build a system, and we've got to move data from point A to point B. And from a very non-detailed view, we can look at it this way. The way that we set this up is we use 2 different addresses to get information from one place to another, and that's what this slide is displaying for you. So we've got our gentleman on the left, and he's computing. He wants to access a web server that just happens to be on the same network that he's on, which, you know, happens like never, but that's okay. They're showing you the network interface card on one side and the network interface card on the other. And then they show you 2 blocks, and they give you an L2 and an L3. Now, those L's are for the OSI model, right? So the OSI model takes, it does come into play here. So the OSI model does come into play, and L2 is layer 2 and L3 is layer 3. So if we think about the bottom of the OSI model, the layer 1 is the physical layer, right? Physical layer. Layer 2 is the data link layer. And layer 3 is the network layer. And we're going to talk about each one of those in this particular slide. So when it shows you L2, L3, what they're saying is this. Physically, we have to travel along this wire right here. We're going to put some kind of wave on here. And I just kind of made some waves. We're going to put some kind of wave on there that can be read by this NIC over to this NIC. And this is nothing more than a stream of zeros and ones, right? So 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0. So on and so forth. And it's just a stream of zeros and ones that needs to be translated by this network interface card over here. That's exactly what we're doing. So at layer 2, what we're going to do is we're going to take electricity and we're going to send it out so it can be read by another network interface card as a series of impulses of either a 0 or a 1. And those zeros and ones are going to be translated by the receiving device so that the information that they actually want to send can be read. Now, in this slide, all we're saying is this, is before we can send the data, we're going to send a couple of addresses. Number 1, we're going to send what's called a physical address. In this case, they're calling it a NIC address, which I don't know where else you see that. Most of the time, it's called a MAC address. I'm just going to cross those out and write the word MAC right there. MAC and MAC. It's called a source MAC and a destination MAC within Ethernet. Is it associated with the network interface card? Absolutely. Every network interface card on your computer has a MAC address. So, pop quiz. If you have a wired Ethernet card and you have a wireless Ethernet card in your computer, how many MAC addresses do you have? You have 2 MAC addresses, 1 for each, right? What if you install another, like a USB 3 to Ethernet device? Now you have 3. What if you unplug it? You're back to 2 again, right? Simple enough. Every network interface card has a burned-in MAC address. We'll go deeper into those in another slide. But what they're getting to you here is this, is there are 2 addresses that you're going to use to get stuff from point A to point B. Around your local network, you're going to use that layer 2 address. And if you want to get your information to another network, you need a layer 3 address. So a layer 3 address is generally used for moving stuff to another network someplace else. However, it's also used by the destination to make sure that the information is for it. So what they're saying here is this: L2 address, L3 address, source and destination on each. When our friend here sends his information over to this web server. The web server is going to read this destination MAC address and identify, is this device's MAC address the same as this? Yes or no? Yes, read the destination IP address. No, with a little exception there, but no equals stop reading. I received this, but it's not for me. I'm going to go ahead and get rid of it. Okay. So if it is correct, this MAC address matches the NIC value, the MAC address value on the web server, it'll keep reading. It'll check the destination IP address. Now, if this value here and this value here are the same, once again, keep reading. Oh, okay. So it has my MAC address and it has my IP address. Sounds good. This is obviously information for me. The next thing you would see would be a segment header, which we're not going to talk about today. And that would identify the process that you should use to read the data that you actually wanted to send. But for now, all they're trying to get into is this. Know that when some device is going to send something to another device, there has to be a protocol or process at layer 2 to interact with the physical media, to put a modulated wave on the physical media and give it an addressable space so that one device can communicate to another one. That's all they're getting into here, okay? All right, now let's go to the next slide. The next slide's pretty straightforward. And this slide just shows you here. It says, okay, well, here it is, right? So this is layer 1 of our OSI model. This is layer 2 of our OSI model. And this is layer 3 of our OSI model. I'm just going to write OSI right here. And, you know, and it's all set and ready. And what we're seeing is there's a communication between these. And in this particular chapter or module, they talk about the idea of the data link layer. You know, this is what we're talking about here. We're going to talk about data link. And the job or the role of the data link layer is now broken up into 2 parts. There is something called the LLC, Logical Link Control, and another sublayer of jobs that are to do by the MAC or Media Access Control. Okay? Now this is actually pretty easy, pretty straightforward. The MAC stuff relates with the physical, right? So Media Access Control means how are we going to put the information on the wire so that it can be read by another device? That's important. What's the format of that? What address space are we going to use? Well, we're going to use MAC addresses because it's the MAC sublayer. So, okay. So we'll use Media Access Control addresses to identify the jobs of the Media Access Control, right? Yeah, absolutely. So how fast are we going to send this stuff, Media Access Control stuff? Is there any authentication that goes along with it, Media Access Control stuff? What is the format of the addresses that we're going to use, Media Access Control stuff? In fact, pretty much everything is Media Access Control stuff except for what they define here with the LLC sublayer, which is a logical link control, which does nothing but just identifies what type of information is in the network layer protocol, right? So the idea is I've got a device, and the device has a method to send binary code to another device. Great. The receiving device can read that binary code. Awesome. Now, we've got addressable space between these two, and these two devices are going to be able to communicate with each other, and this works great on LANs. But if we have to move stuff off of the LAN and get it someplace else, we're going to need another address, and the other address that we're going to use has to be identified inside of the frame header space that we have here. It has to be identified here, and that job is known as the LLC, the logical link control. All this is if you were to write this out, this would be identifying that, oh, the network layer protocol, hey, we're using IP version 4. Or LLC says, hey, we're using IP, why isn't this drawing correctly? IPv6, that looks horrible. You get the basic idea. We're using IPX, SPX, which you're never going to use. But there's a protocol, and it's identifying what it is that the receiving device needs to use to read the addressable space, the second address in the system, and that's what LLC's job is here. So the LLC's job is only to identify what happens up here. If we were to look at a regular frame header, there is a field called the type field. The type field's job is LLC. The type field does nothing more than identify what the layer 3 protocol is. that needs to be read so it can be identified, so it can move forward, we can find the process, and then actually read the data. And that's all we're getting into in this particular segment.